All right. Let me take off my mask here. And I am recording this for future reference. And you can find the link there to my website, mrvchemistry.ca. There's a, we're live streaming apparently. So, okay, so as a summary, quadratic formulas or quadratic equations. That's what we're doing with the Angry Birds. So we're trying to make it fun. But quadratics, they come in three forms, okay? One is ax squared plus bx plus c. Now, usually they're equal to 0, okay? Because you can't really solve them unless they're equal to 0. But they don't put the equal sign in there usually, okay? Where a, b, and c are a number. And let me give you an example. It might be something like 3x squared plus 4x minus 6. In that case, a is equal to 3, b is equal to 4, c is equal to negative 6. So there's numbers, okay, and we just call them ABCs. I call it the ABC formula or the general format, okay? Textbooks like to give you in that format, and your calculator prefers that format because you just enter three numbers and it solves it for us. So we'll come back to the general format. There's a formula in here, John Rick formula, or the y equals formula. That works for all of those, okay? Our preferred format is standard format. And standard format has a y equals, because we like to use our y equals button. And it comes into, let me think here, y is equal to a bracket x minus h bracket all squared plus k. Now again, I wasn't the one that chose all these letters. The A is the same A as in the general format, but that's the only overlap there, okay? And I'll give you an example. Example, negative 3x plus 2 all squared minus 4. We prefer, this is called standard format. We prefer this format because this format tells us three things right away, and we can graph this thing without a calculator and with anything else. So there's a number there and a number there, and that gives us the most important number, which is called the vertex, V for vertex. And the vertex has an x coordinate and a y coordinate. The x is with the x, but because it's in brackets, when we pull it out, it's going to be negative 2, and this part here is negative 4. And so that's going to be negative 4. So we flip the 1 inside the brackets, the x one, because it's inside the brackets, and we put it there at the vertex. And when it comes down to it, I'm going to scroll over here to the side here. When it comes down to it, we can graph standard format without any calculator, just kind of looking at it. This one is 2 backwards, so 1, 2 backwards, and 4 down, 1, 2, 3, 4. And there's the big dot, there's the vertex right there. That's the vertex, negative 2, negative 4. It's like Battleship, okay? We always go left, right first. This is always the x, this is always the y. You can put little arrows on the end, too. And that's the most important part on any quadratic. Now, ABC format doesn't tell us that. It doesn't tell us anything except for the fat skinny factor. So the A thing here and the A thing here is the fat skinny factor. And the bigger the number, the skinnier it is. Okay, and the smaller the number, the bigger the fraction. Okay, so it has to be less than 1. So the bigger the fraction, though, the wider it is. So you can have skinny or you can have wide. This one is 3 times skinnier than a normal. Okay, and what that really means is that if we start at the vertex, this one, I'm going to change this to plus 3. Okay, the reason being is it's down here. The positive or negative means it's opening up, okay, if it's positive, or opening down if it's negative. And that's the A value. So we can still say A is equal to, in this case, plus 3. Okay, so it's the same A here and the same A there now that I've changed it. But what that means, if you start off with the vertex, you always go over 1 square. So this was negative 2, and this is negative 1. So if I go over 1, just count over 1, and then I count up or down A. So I used to, when it was negative 3, I would have to count down 1, 2, 3, and that's why I changed it, because it's going to go off my graph. But in this case now I want to go up 3. 1, 2, 3. There's a dot there, and it's a mirror image on the other side. So if I go over 1 this way to be -3, and I go up 1, 2, 3, I can quickly, without my calculator, sketch that graph all the way up like that, and sketch that graph all the way up like that. And this standard format is really fast once you know that. Because if you are given the graph, you know the vertex, you know 2/3 of your answer. Or if you're given the standard form, you've got 2/3 of the answer by just plotting that point. The only trick is you have to realize that x thing is flipped. So +2 there is -2. And then the a value tells us how far up or down over 1 goes. So you go over 1, up 3, because it says +3, over 1, up 3, and you got 3 dots. Now I prefer 5 dots, but 3 dots is better than nothing. So the rule is over 1, up a. Okay, and hopefully you have this on your formula sheet, which you are allowed on your test, your exam. The second rule here is to get 5 dots is over 2, up. Can anyone remember that? That's a long time ago. Times it by, it's something a, but it's something a. It's a times, close, 2 squared. 4a, okay? So normally, we had, way back when we were doing radicals, we did 1, 2, 3, 4, 5. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25. These are, I called those magic numbers way back when. Well, the first magic number is 1. So when I have 1a, I go over 1, up 1a. When I go 2, it's over 1, up 4a. And if I go over 3, now we'll never do this, but if I wanted to go over 3, so 1, 2, 3, I would go up 9 times a. So 9 times a is 3, so 9, I go up 27. So I'm way up here. But I'm not going to use that because it's going to go way off the graph. But that's the pattern, and it can, 16a, 25a. Essentially, we only need to worry about the first 2, and the first one's the easiest one. You can get a rough sketch of that, and after that, getting the extra 2 points. I prefer 5 points, but if you give me 3, better than nothing, and I'll probably only dock maybe half a mark for not doing the other two points. So this one would be over 2, up 4 times a, 4 times 12. So over 2, 1, 2, and up 12. This is 4, so it'll be way the heck up here. So, and way the heck up here. So we'll continue on, kind of like that, and continue on way up there, okay? So that one's not really a good one to give me 5 dots on. That's just an example. That's the standard format. Okay, and this is the preferred format. If you can put it in that format, basically it's game over. It's pretty easy after that. Now there is a third format, which is called transformational format. And I'm not really keen on it. I don't really care if you know, oh, this is called transformational, that's standard, it's general. You should be able to recognize it too. But transformational format is designed by math teachers to make it so that you can't punch your question into the calculator, just graph it and figure out things from the graph. These calculators are great, but they make your life easier, just like cell phones do now too, right? But math teachers still want, and I do too, want to be assured that you do know how to do the math and be able to interpret what the vertex means and what this stretch means and all that stuff. And so this format is 1 over a, y minus k is equal to x minus h all squared. And basically, it's put in this format so that you can't hit the y equals graph it and get the answer. You have to know that k and h, or rather h comma k, are the vertex. And you have to flip them both. So let me give you an example. 1 over 3, and I'll make that negative. Y minus 6 is equal to x minus 2 all squared. That's an example. In this case, a is -3, and I'll put 3 over 1 just to make it, so what we do is the a is in front, but it's on the bottom, so we have to flip it to the top, so a is 3 over 1. Now it's still negative. You don't flip it positive, negative, you flip it top for bottom. Okay, the vertex, the most important part, is x comes first always, and since it's in brackets, I flip it, so it's +2, and y comes second, and it too now is in brackets. That's why transformational form is kind of stupid, because now you have to flip both, right? So this would be +6. And once you have the vertex and the a, well, we can easily convert to the normal format and going, say, listen, the normal format, the standard format is y is equal to blank, 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 okay? And the x part doesn't change, but the y part, +6, and the a part, -3, -3. So there it is in transformational format. Okay, there it is in standard format. We can graph it really quickly. The vertex is 2, 6, and then it's going to go over 1, down 3, over 1, down 3, and then it'll be upside down. And it's going to be a skinny graph because the a value is skinny. It's 3. It's bigger than 1. We didn't have any fat graphs. And that's it. So that's essentially, now we can go on, and matter of fact, this whole quadratic unit is quite lengthy. It's probably about 1/3 of the course, and we ended up doing it the last part of the course. And it's just the way it works out. And then we lost a few days before, storm day. We lost about a week before Christmas, and we lost a week in January 1st. So we're not going to get through this whole unit. So we're going to basically stop there, finish up our Angry Birds there, and then I have to take a whole bunch of questions off your exam now that don't really apply, because we'll have to cover that next semester or something else, just because of the time frame. But essentially, if you've got the 3 different formats down, and you know how to graph, or go from a graph to standard form, or go from standard form to a graph, and you're really, really good at that, there's very little else that we need to know, okay, for this term. Normally, we would go on. There's still word problems. There's still the quadratic equation, which I really wanted to do, but we can't. And there's factoring and stuff too, which we can't really do. But it is what it is, okay? So that's the summary. Are there any questions about that first? We're going to get into some practical questions, which you've already done. So we've done some of these questions, but I've got some different ones. We're going to do just one of these things, and then I'm going to give you another similar, it's an Angry Birds question, but it's a different one that you haven't seen before. Okay? All right. So here is the sheet here that everyone's got this, right? I gave it this morning. We're going to basically summarize the 3 different ways of attacking this problem and seeing, putting these equations into my calculator to see which of these birds, 1, 2, 3, 4, are going to knock off these 2 pigs. So it's 2. I just basically split over in 2 pages. Okay, and there will be one question like this on your exam, almost verbatim. I'm just going to change some numbers. So you've seen this multiple times. We've already done 5 or 10 questions in December, and then we're reviewing it here, and then we're doing some more. So by the time we finish on Thursday, you'll be quite well versed in these things. Okay, so let's start off here with Redbird. Redbird starts his flight from a point 10, 0. So I'm just going to do a little sketch here because I'm a visual person. I have to see this. So there's my graph. Now, I don't care about these quadrants here. So he's going to start off at 10, 0. So there's 0, 0. So 10. So he's going to start off. He's not starting from 0. 10, 0. He reached the maximum point of 18, way up there, 18. And then he comes back down and hits at 38. So there's 38, there's 10, there's 0, and the maximum height here, he said, was 18. Okay, so the most important point on any quadratic equation, there's my little sketch. It's not very good, but There's the most important point, and that is referred to as the vertex. And so the vertex then would be, well, you know the maximum, whenever you see the word maximum, the maximum is the y value. And they said that the maximum height is 18. So that's the vertex, that's the 18 right there. The question is, where along the x does that hit? What number is that number right there? And so it is, these parabolic curves or these quadratic equations are always symmetrical around the vertex, and so we just have to find, so that means it's exactly in between 10 and 38, exactly. So how do you figure out the exact middle between 10 and 38? Well, we did that in our very first unit, which is on probability and statistics. So it's an average. You get 10 out of whatever on your exam the first time, and then 38 out of whatever on your exam the second time. What's your average? Well, 10 plus 38, two numbers, divided by 2. And so the middle number there is 24. And so the vertex is 24, and we have 2/3 of our answer. Okay? So in standard form, now they're not asking for a standard form, but in standard form, I'm going to write it up here. Standard form is y is equal to blank, blank, and blank. And now in standard form, I know that this is 24 and this is 18. And I put plus and I put minus there because I had to flip it. I don't know A. Okay? Now, down here, there's a whole bunch of blanks here that I have to fill in. And this is not in standard form, is it? This is an A, B, C form. So if I go back to my notes here from earlier on this morning, that's A, B, C format. That's the general format. That's the format that the calculator prefers. So, you know, I did it using visual. I didn't really use the calculator. I did it using, you know, the normal human way. But it looks like, even R squared here, it looks like they want us to do it with the calculator. Okay? So, now I can't remember how to do it with the calculator, but good thing I wrote it down. Okay? So, what we're looking at here is we're looking at a pattern. Okay? What we do is we've got some points. There's a point there, there's a point there, and I figured out a point there. I've got 3 points. I can figure out a pattern from that. So what I'm going to do is I'm going to write these 3 points down in a nice little table. Okay, x on this side, y on that side, and I'm going to write 10, 0, 10, 0. I'm going to write 38, 0. And I'm going to write the third point, 24, 18. 24 and 18. And since I have a pattern now, I can use my pattern thing. I'm going to cheat sheet stat and then edit. Put your x and y values into L1 and L2. Okay, I haven't done this for a while, so I'll have to stat. Number 1 is edit. I got an L1 and L2, and I'm going to put in my numbers. 10, 0, 10, 38, and 24. 0, 0, and 18. There we are. And then what? And then go stat, scroll over, that's what that means, to calculator, and number 5, quadratic regression. Make sure r squared equals 1. Oh, there's one of my answers. R squared equals, well, hopefully, let's see if it works out. So stat, scroll over to calculate, down to number 5, quadratic, just like it says, hit enter twice, and r squared is equal to 1. Bang on. So I can write that in. R squared is equal to 1. What's all the other? What's the A, B, and C? Well, it tells us right there. The A value, the B value, and the C value. Now, this is the calculator preferred method, and the reason we don't want to use it is because look at how many decimals there are in that thing, right? C is negative 34.8979, and it keeps on going. They only show the first 10 digits, right? So it's a weird number. The calculator doesn't care. But if we were to try to graph those weird numbers on here, no way. We're not going to be able to do that. And that's why the calculator method, that's great for the calculator, but we probably prefer standard format, so that's good for humans. Okay? The only overlap, the overlap that we can't figure it out as a human is that A value. But that's the beauty of the system. the A value is the same for general format, this format, ABC format, and for standard format. So this A, negative 0.09, that's the only thing we needed right here, negative 0.0918. Now you can't really see that. It looks like a 2. Negative 0.0918. Okay, so I can put that in here, negative 0.0918. I can write down my B and my C. I'm not going to really reuse it, but it has some blanks here, so I'm going to fill them in. 4.4 and negative 34 point, I'll put 9, I'll round that. Okay, and so in that format, I would do A, B, C format. I'm just going to write the same thing, a negative, my goodness, negative 0.0918. 4.4 and negative 34.9. Now I've got a plus negative here, so it's actually just a negative, so I can get rid of that plus when I punch it in. Okay, and there it is. So I can actually punch that into my calculator now, and I am. Oh, there's a different Angry Bird there. All right, so I'm going to go into y equals, and I'm going to type that in, negative 0.0918 x squared plus 4.4x minus 34.9. Okay, now that's not going to be exact because I'm rounding it, but it'll be close enough. Okay, let's try our second. So that's Angry Bird's number red. There's in, and he's red. I've got my y equals. So now we're going to go on to Chuck, the yellow bird. Now, Chuck is already in A, B, C format. So the A in this case is negative 1. The B in this case is 14. And the C in this case is negative 24. And I don't really need to do anything. If all I'm trying to do is put it into the calculator, well, let's put it into the calculator as it is. Negative x plus, oh, is that the same one? Here it is. It's already in there. Plus 14x minus 24. Now, if I were to graph that, I would be able to figure out, this is going to be negative 1. But I could figure out this is in standard format, so blank, blank, blank format. So this would be, these two numbers here would be the vertex, kind of like up here. It was 24 and 18. I could graph this thing and figure out the vertex and figure it out in standard form. But all I'm going to do at this point is put into the calculator, and I put in my ABC values in the calculator, and we're good for right now. Okay? Unless it asks for what's the vertex. All right. This particular question is on the Bluebird. We know that the maximum is 13, and so we know that the vertex is something 13. Most important point. So let's figure out what the x value is. And so the x value is halfway between this point here and that point there. The Bluebird starts on the ground at 0 and goes all the way up to 13 and then down and hits the ground again at 26 meters or feet or whatever it is here. So halfway between 0 and 26 is 13, and that means that goes up to here. So this is 13, that's 13, so we got a vertex of 13 and 13. And that's what goes into here, 13 and 13. We are 2/3 done our equation. This is negative though, because it goes into brackets. The only thing we're missing at this point is the A value. How do I get an A value? Well, it's not listed there anywhere. So we could go from the vertex over 1 and count up or down, but it's too hard to count. Like it's not accurate enough. Okay? And the answer is probably going to be some weird decimal like this, and so we can't do it by hand, visual inspection. So we have to use the calculator and find the pattern. Let's see if we can set up a pattern here. This point right here is 0, 0. This point right here is 26, 0. There's 2 points, and the most important point we already know is 13, 13. And since I have 3 points, I can use that as a pattern or a table, and you can actually write that in. If you want to put pattern or tables, right? Table of values. This is my x, this is my y. I can go stat edit, calculate a quadratic equation, and I could figure out that a value. Okay? This is almost a repeat of question number 1. So, how do I do this? Second function quit. Oops. Mode. Second function quit. There we are. All right, stat edit, and it's 0, 0, 26, 0, and 13, 13. So there they are there. I'm going to go stat now, scroll over to calculate, down to number 5, quadrag. And the only thing I really know, r squared is equal to 1, that's good. I could write these things down, there's an ABC format, and I could type those things. I actually am going to write that down, just up here. Y is equal to negative 0.0769 x squared plus 2x plus 0. And then I'm going to put r squared equals 1. Okay, that would be similar to question number 1 there. That's ABC format. Okay, but the only thing I really need, since I've already got this down here, is this first number, negative 0.0769. There's my equation in standard. There's my equation in general. It doesn't really matter which one I use, but I'm going to use this one because it's easier to type in. Y is equal to, and we got purple, negative 0.0769, delete, and it's not going to be x, it's going to be bracket, x minus 13, bracket all squared, and it's plus 13, and there we go. So bluebird's in there, negative 0.0769 x minus 13 all squared plus 13. And we only have one more to do, one more blackbird to do. So what do we have here? Okay, we have a table of values. So it's the same thing as before. Basically, we're going to use our calculator, stat edit, pick any 3 numbers. I don't really care. You can pick this number, and that number. Any 3, or you could do them all if you wanted. But any 3 will work. So stat edit, and I'm going to say 9 and 7.5, and I'm going to say 12 here, and 24, and the last one I'm going to do 17 and 31.5. Okay? Any 3. Okay, you do need a minimum of 3. Stat, scroll over to calculate, down to number 5, and they already have ABC format. Okay, there's no brackets there. And so let's see what they say. R squared is equal to 1. And look, it's a nice, simple one. Okay? So A is equal to negative 0.5 x squared, 16x, and negative, so get rid of the plus, negative 96, and r squared is equal to 1. So this one's a nice, simple quadratic. So I'm going to enter that last one into, okay, it's similar to what we had before, apparently before Christmas. Negative, actually, no, it's not. Similar numbers, but this is in standard form. Negative 0.5 x squared plus 16x minus 96 there we are. Second function quit. And now the only thing I have left to do is graph it. Now let's see which bird wins. So I've got 4 of these equations in here. 1, 2, 3, 4. I've got them color coordinated. And now I'm just going to hit graph and see if all of them line up in my graph. Now I've got my window set already, but we'll show you how to set your window too if it doesn't work out. So far everything fits. There's blue. And there's black. So everything fits nicely. And we just have to figure out where are these guys on the graph. And King Pig is located at 21 and 19.5. So I can just use my scroller and go up here to, I want 21. So that's this way, 21, roughly. 21.06, close. And 19.5, so I have to go down to 19.5. And I don't know if you can see that, but I'll zoom in there. You've got, that'll be Blackbird, right? Blackbird is the one on there. Now, that's if you just hit, I just hit the scroll thing there, the little D-pad. But if we want to see it on a table, if we can go second function table, it'll bring up the exact value. So we just have to go down to number 21. Down to number 21 and see, okay, which one is 19.5? So red bird's at 17, yellow bird's way off at negative 171, blue bird's at 8, and blackbird's at 19.5 exactly. So that's why we also picked Blackbird. Now, since we're in the table, let's down and go look at Mustache Pig here. He's at 9 and 21, so we have to scroll up here to number 9, and we'll see which one is at 21. So red's at negative 2, yellow bird's is at 21, and 11 and 7.5. So the answer in this case would be yellow bird. Okay? Now, there's an extra question which I've never asked before. Which bird flies the highest? Well, you tell me. Blackbird. Okay, so which one flies the highest? Black. And it says, what is their maximum height? Well, how can you tell their maximum height? Vertex. Okay, we want the second number, the X and the Y. So this is go back to Blackbird, and we got it in the wrong format, don't we? Okay, so I want to show you, we want to find the vertex of Blackbird. It's in standard format. Well, let's take a look here. Okay, how do you find the vertex? Cheat sheet. Oh, y equals, enter your quadratic equation into calculator. Well, we already did that. Blackbird's already in the calculator right there. Okay, so it's y equals, it's y4, but that's okay, it's right there. It's already in y equals. So then, go second function trace calc. Okay, second function trace calc right there. Trace calc. And what do we want? We want to find the maximum. Now, if we wanted to find the minimum, if it's a UE graph instead of a upside down U, okay, then we'd find the minimum. By the minimum and the maximum, that means find the vertex, or the one part of the vertex. So we're going to go down to number 4, the vertex. Now, here's the problem. We got 4 graphs on there because that's what we wanted. In this case, we don't want the vertex. We can find the vertex of any of those 4. And so it's asking you, hey, where's the which equation are we talking about? So right now, the X is on our red line. We want it to be on our black line. And we want to find this point right here. So I have to left bound and right bound the black curve. And so I can use my arrow key to select, right now I'm on yellow bird. You can see up here it says yellow. And if I use my up arrow, now I'm red. Now I'm on black. And that's what I want. So the up down arrow key will select which graph you're talking about. And then the left right will indicate where you want to be. And you want to be on the left of the vertex somewhere. Because this calculator is going to take a sampling. It's going to try to guess somewhere between the left and the right where the vertex is. So I want to be to the left of that top little point. And I hit enter. And it set a little line. I don't know if you can see that. It set a little line. It's a lot easier to see on these graphing calculators, these color graphing calculators, than on the black and white ones. And now we want to go to the right bound. And so I scroll over to the right a little bit and hit enter. And so we want the calculator to guess between those little arrow things. Somewhere in there is our answer. And they're saying, what is your best guess there, Jeff? And so I'm going to say my best guess is right about there. So my guess, okay, if I were to guess, it's 16.06 and 31.998. What would you guess the vertex to be? 16 and 32. Let's hit enter and see what it says. The maximum is 16.000004, 16 and 32. And so we can actually put in here vertex 16 and 32. And now we can answer what bird flies the highest. We know it's black because we saw it. What's their maximum height? 16 and 32. So their maximum height is 32. Different type of question. Okay? Now, I got one more bonus here. It says calculate a red bird's trajectory in general format. And we already did that. There's general format, r squared. So we already did that. So C reverse. Cool, that's a lot. Okay, but hopefully it'll bring back memories, hopefully fond memories. But if in doubt, use your calculator formula sheet here. Use your calculator. The only thing I haven't shown you how to do is how to set your window. Right now, my window is set, but I knew that all my birds are starting at 0, and they're going to have a height. Okay, so it's going to be the top right-hand quadrant. So I set my window, my x minimum and my y minimum to be 0 and 0. So if you take a look here, my x minimum is 0, my y minimum is 0. And then how high did I want to fly? Well, we know now that the maximum is 32. But if I didn't know that, I would have this thing set at 10, and then my graph would only go up to 10 and it would go off the screen. So I just have to extend it on the y, so then I'd have to change my window to something bigger. And same thing on the x. If it goes past on the x, then I just have to make that number bigger until everything fits on the one graph. Okay? So 40 and 40 seems to work well for that question. And so you can maybe write that down too. 40 and 40, and there's a beautiful window. All right.